Braking systems rely on the scientific concept of friction to slow or stop a moving car. Because both car design and brake systems have changed over the years, there became a need for different friction materials. Vehicles have changed from mostly heavy, rear-wheel drive layouts that provided a 60-40 front-rear split in brake design to lighter, primarily front-wheel drive layouts with normally an 80-20 split. In order to reduce weight and raise fuel mileage requirements, brake components became lighter and smaller. This reduced the ability to transfer heat from the friction or rotor to the atmosphere. Federal motor vehicle laws governing brake requirements for new car production have become stricter as well. The maximum force a driver can exert on a brake pedal has been reduced, yet the stopping distance requirements have remained the same. Just as a tire's ability to grip the road changes from dry conditions to wet or icy conditions, the ability of a brake pad to perform is dependent on the materials used in both the brake pad and the rotor. There are essentially 4 types of materials used in brake pads: semi-metallic, low metallic, non-asbestos organic, and ceramic. Regardless of the type of friction, all formulations use 5 main elements. Abrasives provide the stopping power. Fillers allow the fine-tuning of friction. Fibers provide the skeletal framework. Resins, adhesives, and binders all hold the friction material together. And lubricants help give the brake even clamping pressure. Semi-metallics may contain up to 50% iron and steel and also use high amounts of graphite, a main component of dusting. However, semi-metallics are often the least costly to produce, but do well in high heat or severe duty conditions. Low metallics may contain up to 20% iron and steel, but contain more complex lubricants than graphite, which make them cleaner and slightly more expensive to produce. Non-asbestos organics contain no iron or steel, but use a wider variety of other metals and fibers and are more expensive to produce. Ceramics also contain no ferrous metals and rely on a specialized list of components that make them the most expensive to design and produce. Low and semi-metallic pads offer the high stopping power but can create more noise and dusting. Ceramics provide desirable NVH qualities such as low noise, minimal dusting, and smooth and consistent pedal feel.